Hi everyone. Today I am going to talk about how to find the maximum likelihood estimators using a super simple example. So in statistics, as an example, when you consider the simple linear regression model, we need to estimate the unknown parameters. So in that case, we can use several techniques. For an example, we can use the least squares method to estimate the unknown parameters. So that is the most commonly used method in simple linear regression model, or else we can use some other techniques like the maximum likelihood method or Bayes estimation method or method of likelihood estimation method. So when you consider the maximum likelihood estimation with the other type of estimators, as an example, when you compare it with the least square method, the most important difference between those two is that for maximum likelihood estimators, we have to assume that the random variable follows a certain distribution. So let's see how to estimate this maximum likelihood estimators. So first I am going to show you the probability density function of the x. So the probability density function of x given theta is equal to theta times x to the power theta minus 1 when x is between 0 and 1, and the probability distribution is 0 when x is outside within this range. So if you are familiar with the probability density functions, you may find that this is one of the beta distributions. So now I am going to estimate the unknown parameter theta using maximum likelihood estimation method. So first I am going to talk about the steps of the maximum likelihood estimation. So my question is, find the maximum likelihood estimator of the theta. So there are 4 steps that I am going to follow here. The first one is you need to find the likelihood function. So in this particular example, we assume that there are n observations, and these all n observations are independent and identically distributed. So in that case, the probability distribution function of all these x variables is equal to this equation. So based on that, we can find the likelihood function by simply taking the product of all these probability density functions. The next step is we have to find the log likelihood function. To find the log likelihood function, what we have to do is we have to take the log of the likelihood function. So in most of the situations, it is very convenient to us to work with the log likelihood function rather than the likelihood function itself, because because of the computationally efficiency of the log likelihood, and also we can replace the likelihood function with the log likelihood function, because this log likelihood function is a, or when you consider a log function, is a monotone function. So because of that, it's easier to work with the log likelihood function. So the next step is we have to find the first derivative of the log likelihood function, and after that we can equate that first derivative to 0 to find the estimator of the unknown parameter theta. But in this point, we don't know whether this estimator is a maximum likelihood estimator or not. So because of that, we follow this fourth step. That means we are going to find the second derivative of the log likelihood function and show that estimator is a maximum or not. So as you know, in calculus, if you find the second derivative of a particular function, and if it is a maximum, if it is gives you a negative value, that means what? That particular estimator will attain its maximum value. So the same theory applies here also. So these are the steps that I am going to follow in this example. So now I am going to do this based on the example that I have shown you earlier. So first step is that I need to find the likelihood function of this random variable. That means I have to simply take the product of this I have to take the product of the probability density functions of this random variable. Since there are n observations, I need to take the product of these probability density functions. So you can see this theta is independent of this I, so you can factor that out. So there are n theta values, which you can write it as theta to the power n, and here you can write the other term as the product of xi to the power theta minus 1. So this is our likelihood function. So when you are going to take the derivative of this one, I think it's a little bit of complicated. Because of that, we are going to calculate the log function, because here we have this product. So if you have this product, sometimes it's complicated to use this likelihood function itself. So what we are going to do is we are going to take the log of this likelihood function. So in this case, we are going to use some properties of log. That means if you have something like this, that means if you want to take the log of a product of a times b, then you can write it as what? Log of a plus log of b. Also, if you have something like this, log of x to the power n, you can write it as what? N times log of x. So based on these two properties, I can write this initial likelihood function as a summation of two components like this, because when you take the log of this function, it will be equal to what? Log of theta n times this product term. So based on these properties of log, I can split it into two parts by using this summation. So the first part, I will have log of theta to the power n, but based on these properties of log, I can write it as n times log of theta, and also I have this term log of product of this xi to the power theta minus 1. So then I am going to use another properties of log. That means if you have a product of log like this, then you can write it as a summation of log like this. So this will be equal to n times log theta plus the summation of log of xi theta to the power log of xi to the power theta minus 1. After that, you can use the power rule of this log, and you can write this as, or you can further simplify this as n times log theta plus theta minus 1 to the power summation theta minus 1 times summation of log of xi. Okay. After that, so this is my basically the second step. Now I'm going to continue my third step. That means I'm going to take the first derivative of this function with respect to theta. So here you can see here in this case n times log of theta, this n is a constant. So when you take the derivative of n of log theta, it will be equal to n over theta. Plus you have this theta minus 1 times summation of log xi. You can see here in this expression there are two parts. The first one is theta times summation of log xi, and the second part is what? Minus 1 times summation of log xi. When you consider the second part, which is the minus 1 of summation log xi, is a constant and it is independent of theta. So when you take a derivative of that one, it will be 0. So the only part that we have to consider is what? We have to only consider the theta times summation of log xi. So since the summation of log xi is again a constant, when you take the derivative of this one, it will be equal to sum of log xi. So this is the equation of the first derivative. So in order to find the estimator, what we can do is we have to equate the first derivative to 0. That means we have to equate this n over theta plus sum of log xi to 0. So when you do that, you can find this estimator of theta hat which is equal to negative n divided by summation of log xi. So this is our estimator, but we still don't know whether this is the maximum likelihood estimator or not. To verify that, what we can do is we can take the second derivative of the log likelihood estimator. So here you can see this is the equation of the likelihood function, I mean the first derivative of the likelihood function. So in order to find the second derivative of the likelihood function, we can simply take the derivative of this one. So here you can see the second term is independent of theta, so the derivative of that will be equal to 0, and we have to only consider the first part. So you can find the derivative of the second part based on the power rule of the derivatives. So when you do that, you can see it will be equal to negative n divided by theta squared, and here you can see this is always negative because this theta is always a positive value and n is also a positive value. Because of that, this negative n divided by theta squared is always negative. So that means the second derivative of this log likelihood function is negative. Because of that, this will be a maximum value of this estimator. So our maximum likelihood estimator for this example is equal to negative n divided by summation of log xi. Alright, so this is about maximum likelihood estimators. So if you think my video is useful to you, please subscribe my YouTube channel and wait for my other videos in several topics in statistics. Thank you very much.